Section 1.6, day 2. So we're jumping into rational and quadratic type equations that we've talked about before. But we're going to be doing equations with rational exponents. And notice you got to check them. Okay, we're still into that needing to check these. Okay, so we'll see that. Isolate your term with the rational exponent. Raise both sides to the reciprocal power, which is what we did verbally in the previous problems, and then solve from there. Okay, so here we go. On this, I'm thinking, and I'm sorry that we can't type it a little bit better, guys, but that is an x plus 2 to the 1/2 power. You can write that better than we can type it. All right, so if it's to the 1/2 power, I'm thinking that I need to raise, don't forget, I'm going to raise this in a minute, what you know about exponents. If I raise this to the 2/1 power, those would cancel, right? Because power to power you multiply, and now the x plus 2 would be to the first. So that's why we say raise it to the reciprocal power. Okay, I'm just going to make it a little bit easier. Instead of writing it on both sides, I'll just put a big bracket and say I'm raising the entire thing to the reciprocal of that 1/2. That means I'm squaring both sides. The left-hand side then will become x plus 2, because it would be to the first power, equals 6 squared is 36. So if we solve, we'll get x equals 34. Remember, when you square something, you create possible extraneous roots. Okay, so notice I am not boxing that until I do my work for my checking. So for my check step, I only have one answer there that I'm checking. So 34 back into the original. 34 plus 2 is 36. And 36 to the 1/2 is supposed to equal 6. Well, 36 to the 1/2 is 6. Remember, it's only plus or minus, guys, if you put the square root in. Something to the 1/2, that square root, if you will, if you want to think of it that way, it's already part of the problem. So it is just 6 equals 6. That's a check. And now I can go back and actually box my answer of x equals 34. All right, on this one, to the right, number 2, I'm going to isolate my x minus 2 term, right? Isolate the term with the rational exponent, because to me, I'm still looking at that as a, ooh, what does 3/2 mean? That would be a square root, and the 3 would be the power or the exponent. So the 2 is the root, right, because it's in the denominator. The 3 is the power because it's on top. All right, so anyway, I'm isolating that equals -27. And then real quickly, I would be saying that the reciprocal of 3/2 is 2/3. So I'm going to raise both sides to the 2/3 power. Okay, the 3/2 and the 2/3 are going to multiply to be 1, so they're going to cancel each other out, and I'll just be left with the x minus 2. On the right-hand side, I need to be careful to make sure that I know what to do with the -27 to the 2/3 power. Okay, so we'll talk about that. I'll leave that part alone, x minus 2. So remember what we were just saying at the start, reviewing. Okay, so the 2 now on this side is the exponent. The 3 is the root. So that means cube root of -27 squared. And think about how you're going to do that the easiest, especially if you didn't have a calculator. The cube root would be the easiest thing to do that time first. So the cube root of -27 is -3, and then it's just going to be left with being squared because we've already done the cube root. So now you're looking at x minus 2 equaling, well, -3 times -3 is 9. Looks like I'm getting x equals 11. Sorry about that. So if x equals 11, I now need to do that check step again, the thinking would be because I squared something, right? Because we raised it to the power of 2/3. So the 2 is the squaring. So checking this, if I plug in 11, 11 minus 2 in the original problem would be 9. So we're looking at 9 to the 3 halves plus 27 is supposed to equal 0. Okay, 9 to the 3 halves, that means the square root of 9, which is 3, and 3 cubed is 27, plus 27 is supposed to equal 0. And so you're going to tell me 54 does not equal 0. That's a big no. And therefore, since that's a big no, 54 does not equal 0, then you're going to tell me that x is just no solution. Okay, so you would be putting no solution in the answer blank if it were a quiz. Okay. And then some teachers might want you to say, yeah, it's no solution. And even me, I might have you on the answer blank for a quiz, maybe right under it or something, to tell me that x does not equal 11, because then we can see that it was up here in your work, or we are going to have you lightly cross it out. Okay, just as long as you understand that the answer you're going to give me in the answer blank is no solution. Okay. All right, let's practice with this one on number 3. So maybe you want to try it yourself if you're starting to feel comfortable, and then come back and join me. So I'm going to raise both sides to the 3 halves power. That'll make it x minus 1 equals 4 to the 3 halves. And 4 to the 3 halves is where I need to start thinking. So the square root of 4, because the 2 should be the root, because it's in the bottom. So the square root of 4, now you're putting in the square root, right? You are the one that put in that 3 halves. So if you put in the square root of 4 is plus or minus 2, and then we need to cube it. So you're telling me x minus 1 equals plus or minus 8 if you cube those. Therefore, x equals 1 plus or minus 8. Don't leave it there. Do the math. So if you're going to do 1 minus 8, we'll have negative 7. 1 plus 8 would give us 9. I'm not boxing either one of them, okay, until I check. And for that check step again, please just make sure I can follow along with you, that you are checking negative 7 maybe first, whichever one you're doing. Back into the original, negative 7 minus 1 would be negative 8 to the 2/3 power is supposed to equal 4. All right, negative 8, and that's a cube root because it's in the bottom. So cube root of negative 8 is negative 2, and negative 2 squared on the left would be 4. So 4 does equal 4. That's a good. It checks. If I'm checking x equals 9, back in the original, 9 minus 1, so it would give us 8 to the 2/3 is supposed to equal 4. Once again, the cube root of 8, which would be 2, and 2 would then have to be squared to equal 4. 4 will equal 4, and again, that's a check. Okay, so I literally get to box both of those. Both answers would be legitimate for the quiz. All right, next, let's talk about quadratic type equations. Review those and kind of hit those hard a little bit. So the one big thing, guys, is remember, do not divide both sides of an equation by a variable. When you do, you eliminate x equals 0 as one of your possibilities, as one of your solutions. So always think, instead of dividing through by a variable, keeping that variable, writing the equation in standard form with 0 on one side, and then solve by factoring. Okay, so solve by factoring. So if x or a variable was in every single term, instead of dividing through and dropping it, you would want to move everything to one side and just factor out that GCF. Okay. All right, let's practice. So here we go. Number 4. If I see this is where we're talking about. Definitely don't divide both sides by x squared, okay, because you drop answers. And I think you can see that by, if you were dividing both sides by x squared, you would turn the left into an x squared, and now you would think it's quadratic, and you would think that there were only 2 answers. Versus the highest power being x to the 4th here, there should be 4 answers. Okay, so keep that in mind. All right. So let's move everything to where the higher power is. Factor out our GCF of 3x squared, which would leave us with x squared minus 16. I notice the difference of perfect squares there will continue to factor, so our x squared minus 16 is turning into x plus 4 and x minus 4. And therefore, we're going to get x equals 0 from the 3x squared equals 0, that factor. Notice you're going to get x equals 0 twice. So you should be telling me double root. And then x is also going to equal plus or minus 4 from those last 2 factors. So think about this answer. What did we just write in there? For full credit, that is how many answers? Well, there's 2 zeros, a plus 4 and a negative 4. So that's 4 answers, and that's what we would expect with that being the highest power to the 4th. Okay, so keep that in mind. Next, we're going to look at this one. Okay, we got a trinomial. Remember, you should see this, I hope, as quadratic type. And what we mean by that, again, is that this middle term has half the power of that first term. Okay, that's your tip-off that it's quadratic type. Remember this middle term, that's really supposed to tell you the key, saying we want to write this in terms of x squareds. So if you think of it that way, that should be telling you that in the front of each parenthesis, you should be putting x squared. Well, think about that. X squared times x squared, if you multiplied that back out, would give you x to the 4th. And that is what we desire as our first term. Okay, that is matching that x to the 4th right there. All right, so now you should be able to just completely ignore the x to the 4th and the x squared now that you've taken care of that part. And you should be able to go to worrying about the numbers that add to give you negative 4 and multiply to give you negative 32. So those numbers would be negative 8 and plus 4. Okay, this brings up an important review. Okay, we've talked about this a lot. This is sums of perfect squares. Is there such a thing? Is there a way to factor sums of perfect squares? And that answer better be no, unless I'm allowed to have imaginary numbers. Okay, so remember that does not factor at that point. Okay, that was one of our mistakes in the past. And so continuing on then, we're going to say either x squared minus 8 equals 0 or x squared plus 4 equals 0. All right, so this one, x squared equals 8. If I extract square roots, right, like we've done before, so I'm putting in the square root, then you're going to tell me x equals plus or minus, because you put in the square root, and the square root of 8 is 2 root 2. Okay, or if I take x squared equals negative 4, and I then keep going and thinking, I'll go ahead and extract square roots, I see that I'm going to be taking the square root of a negative number, and so that's going to involve imaginary numbers. We have done that. We've taught it to you, so go ahead. You're just going to really want to pay attention to directions when you're on a quiz or a homework. Okay, if it says solve over the real numbers, of course don't give me imaginary numbers. But if it says that you can have imaginary numbers, okay, or complex numbers as we call them in our chapters in our workbook, then go for it. Okay, so we are taking the imaginary numbers since we have done that, and therefore this was going to say x equals, well, if you take out the I for the -1, you'd have I root 4, which would be plus or minus 2i. Okay, and therefore I'll box this. Think about how many answers that is. Because of the plus or minus, that's really 4 answers, and we should expect it to be 4 because that highest power was 4. I will just say, guys, or you can think about this as the following, and I'm going to emphasize the word think. Okay, so if you're thinking about coming from this step up here, and you are thinking about saying, well, you know what? I can force this to be difference of perfect squares. The x's would go in the front, and the square root of 8 is the square root of 8, and one's plus, and one's minus. If you multiply that back out, I completely guarantee that you're going to get x squared minus 8. Okay, I agree with that. And likewise, if you want to think of it this way, you could take this factor right here, which we said sums of squares don't factor unless you have imaginary numbers. Well, the square root of x squared would be the x in the front of each. The square root of 4 is 2, but you're just going to put an I with it, 2i and 2i. Again, make one plus and one minus. So we saw this when we did the imaginaries. Multiply those out. Convince yourself. If you multiply out x plus 2i, x minus 2i, verify that you get x squared plus 4. And indeed you do. Okay, equals 0. And now I just like this because 1, it tells me you understand how to factor. 2, I love factors because I see 4 factors and I know that I'm going to get 4 answers. Okay, it helps me to visually not forget the plus or minus that some of you might forget. But now why do I keep emphasizing that you can think about it this way? Well, the reason that is because we don't typically, and we'll write that here, we don't usually have roots or i's in factors. Okay, so when we start talking about just factors as answers, usually you can't have i's or roots in them. So we'll say, but we don't usually have roots or i's in factors. Okay, but if I see you put that on your paper as far as your thinking, what I just did above here, right here, as far as seeing 4 factors so that you don't forget that you have 4 answers, I'm not going to complain about that. That's great if it's part of your work. Okay, it just can't be a final answer. All right, we'll talk about that more. Okay, so I'm going to steal kind of the numbers in 5 so that it's a little bit easier. So notice we have the number -4 and the -32. I'm going to use that for the next few problems, guys, and we'll already know it factors into the -8 and the +4. Right, so notice on this one, again, we have a 4, a -4 in the middle. We have a -32 at the end. So I'm hoping we can make the connection that, again, this is a quadratic type. Why is it quadratic type? Because the power on the middle term is half of the power on that first term. Remember, this guy is supposed to be the key. That's supposed to be the one that tells you that's what goes in the front of each of the parentheses. And if you verified that, right, think about multiplying them out. X to the 1/2 times x to the 1/2, you would add the exponents. You would get x to the first. Okay. All right, so then at this point, the numbers that now add to be -4 and multiply to be -32 are, again, the -8 and the positive 4. And now we're on our way to solving. So you're telling me that x minus x to the 1/2 minus 8 equals 0, or x to the 1/2 plus 4 equals 0. All right, we'll solve each one separately. So x to the 1/2 equals 8. I'm going to do my new method of raising both sides to the second power. And if I do that, I'll have x equals 64. Remember, I raised it to a second power, so I must check that answer. Okay, so we'll do our check step in a few moments. Let's do this side over here. Okay, so x to the 1/2 would have to equal -4. Raise both sides to the second power, and we'll get x equals 16. All right, so 64 or 16, and definitely we need to be showing that check step. So when x equals 64, back into the original, I'll have 64 minus 4 times 64 to the 1/2. Well, since that square root is already there, it would just be the square root of 64 is positive 8 minus 32. Again, don't stop there, keep going. 64 minus 32 minus 32 equals 0. And yep, 0 does equal 0. That's a good one. All right, checking x equals 16 then, and showing that work. We would have 16 minus 4 times, well, 16 to the 1/2. The square root of 16 is 4, minus 32 equals 0. So we're looking at 16 minus 16 minus 32 equals 0. And so -32 does not equal 0. That one's a no. So 16 does not work. I'd be lightly crossing that out or showing it in my answer. We'll talk about that in class. And x equals 64 is the only one I would box. Okay. Notice again those same numbers over here for 7, right? You've got a trinomial, 3 terms. And again, quadratic type because this exponent in the middle is half of the exponent from the start. That means this one is supposed to be the key. That should be telling you you get -1, x to the -1 in both of the parentheses. Verify that. X to the -1 times x to the -1. Multiplying like bases, you add the exponents, so you would get x to the -2, which is what you have. Okay, so we're good. Same numbers that add to be -4 and multiply to be -32 will be the -8 and the +4. And now we're ready to solve each of those. So you'll have x to the -1 minus 8 equals 0, or x to the -1 plus 4 equals 0. Do each one separately. So x to the -1 equals 8. Well, x to the -1, I don't like negative exponents, so I'm going to go back to our rules of exponents and make that 1 over x equals 8. Maybe I'll change this to 8 over 1 and just solve that proportion, right? A fraction equaling a fraction. If we cross multiply, you would have 8x equals 1. So x must equal 1/8. Okay, and we won't box that yet, okay, until we talk about it. And then same thing over here. We've got 1 x to the -1 equals -4. So that's really 1 over x equals -4 over 1. Again, I'll cross multiply. So -4x equals 1, and x will equal -1/4. Okay, we'll put or between it. Now, did we do anything weird this time that makes us check our answers? Well, we didn't square both sides of our equation, right? The only thing I guess we have to worry about is you should think this original equation, if those are x to the -2, you should think that those variables are in a denominator. So really you just need to make sure that your denominators aren't 0. Well, if x were in the denominator, such as it is in this step, x just can't be 0. Okay, so we're going to be fine with our two answers here that we got, and therefore we're going to be able to say that x equals 1/8 or -1/4. Okay. All right, in 8 then, again, notice the -4 and the -32. I hope you still see this as 3 terms. Once again, this is a quadratic type because this exponent is half of that exponent, right? 3/2 is half of 3. So again, this one is supposed to be the key. That would go in the front of each. So x to the 3/2 in both sets of parentheses. And the numbers to add to be -4 and multiply to be -32 once again are -8 and +4. And now we're ready to go with each one separately. So x to the 3/2 minus 8 equaling 0, or x to the 3/2 plus 4 equaling 0. All right, so x to the 3/2 equals 8. You're going to raise both sides to the 2/3 power. And when you do that, 2/3 times 3/2 is 1, so you just get x to the first equals 8 to the 2/3. Okay, which should mean to you the cube root of 8, which is 2, and 2 squared, which is 4. I'm not boxing it because I did raise things to powers. In fact, I squared something, so I do have to check this. On this side, I've got x to the 3/2 equals -4. Clean that up a little bit. And if I raise both sides to the 2/3 power again, I will have x equals -4 to the 2/3. I don't want to do that too quickly. I want to make sure I don't mess it up. Okay, so this is really x equals, so it's the cube root of -4 and squared. And we said that order doesn't matter, but cube root of -4 doesn't sound necessarily friendly. So maybe I will do the squaring first. So I'll go ahead and make this the cube root of -4 squared. -4 times -4 is 16. All right, and then the cube root of 16, if I make prime factorization, this would be 2 to the 4th. And so you should realize that that would be 2 times the cube root of 2. If I just leave a little bit of space in there. All right, looks like we are ready to check answers. Okay, so here comes those check steps. Make sure in the check, I know what you're checking. So here's x equals 4. Back into the original, I would have 4 cubed minus 4 times 4 to the 3/2 minus 32 is supposed to give us 0. 4 cubed is 64 minus 4 times 4 to the 3/2. The square root of 4 is 2, and 2 cubed is 8. Okay, so that simplifies to be 8 minus 32 equals 0. So 64 minus 32 would indeed give us 0 equals 0. Okay, so that's a good check. And then x equals, yeah, let's work with something messy here for a second. So if I go with x equals 2 cube root of 2 that I'm checking, well, I can manipulate that anywhere. I just notice, thinking ahead, that the cube root of 16, which we had up here, 2 steps above it, okay, if you'll think about that up there where I just put that star, the cube root of 16 is equivalent to that, so I'm going to go ahead and say that's an easier form to check. So I'm going to use cube root of 16 when I'm plugging this in. Okay. And so I might even think of it as 16 to the 1/3 in places. So in that first step, that's exactly what I'm going to do. 16 to the 1/3 cubed minus 4 times 16 to the 1/3 to the 3/2 power minus 32 is supposed to equal 0. All right, 16 and 1/3 and 3 do cancel to just give me to the first power. So it's 16 minus 4. All right, power to power here, 1/3 times 3/2 is 1/2. And 16 to the 1/2 is 4. Minus 32 equals 0. All right, we're looking at 16 minus 32 equaling 0. And negative 32 does not equal 0. That's a big no. Those aren't equal. So therefore, if I'm going back to do my boxing, looks like x equals 4 worked, and lightly crossing out 2 times the cube root of 2. Okay. All right, lots of stuff going on here, but hopefully using those same numbers over and over are helping you figure out this quadratic type. Okay. All right, so here we go. Number 9. Maybe you're recognizing that -4 and that -32 again. Maybe it will be helpful if I rewrite this and convince you of something. Do you agree number 9 is the same as this? I'll leave that first part to look like that. But could I write the next one as -4 times 1 over x minus 3 minus 32? Now it looks a little more familiar to the previous problems. Okay, so once again, why is this quadratic type? Hopefully you're thinking this exponent here is half of this exponent here. Okay, meaning this one is supposed to be the key, right? So you're supposed to have 1 over x minus 3 in the front of each of your factors. Okay, if I just clean that up a little bit. All right, I think you're going to want some brackets since you have so many other big parentheses going in. So we'll factor in these brackets equals 0, and in the front of each one, you've got 1 over x minus 3. The numbers that add to be -4 and multiply to be -32 again, -8 and +4. And we're ready to go. If I set this factor equal to 0 and move the 8 over, I'll have 1 over x minus 3 equals 8 over 1. Or if I do the same thing with this one, set the factor equal to 0 and move the 4 over, it'll be equal to -4. Again, I'll put it over 1 and probably be doing my proportions again. Okay. So if I cross multiply, 8 times the entire quantity of x minus 3 would be 8x minus 24 equals 1. So 8x will equal 25, and x will be 25/8. Okay. Over here, if I distribute -4 to the entire quantity of x minus 3, we will have -4x plus 12 equals 1. -4x would equal -11, and x will equal 11/4. Okay, we'll put the or in there. And then for this one, I didn't do anything fancy, guys, right? I didn't square anything. I didn't raise it to a rational exponent. So I guess the only thing you have to worry about is that there is a variable in the denominator. So if you look up above, x can't be 3 from those denominators. Neither one of these answers is 3, and therefore you are safe to go ahead and say that x does equal 25/8. Just want to change colors on you. X does equal 25/8 or 11/4. but I'll put a note here that you did at least check that the denominator is not 0. Check denominator is not 0. Okay, so you've always got to watch for that. All right, so hopefully that gets down the quadratic type for you, makes you a little more comfortable with the things that you could possibly see. Okay. Okay, we're back to this type of problem. I hope you see this as 2 terms, and I hope you see a GCF. What is that greatest common factor that we've practiced with several times? These 2 terms would have an x minus 1 you could take out. And you're going to take it out to the lower power. So x minus 1 to the 1/2 power. Big bracket. What do you multiply this by to get that first term? Well, of course, it's going to be an x minus 1 because when you multiply like bases, you add exponents. So you really should just be asking yourself 1/2 plus how many halves would be 5 halves. And I hope you'll tell me it's 4 halves. Okay. And the reason then, if I'm going to go ahead and simplify in my next step, is I'll go ahead and make that x minus 1 to the squared term. Maybe I'll leave it there for seeing it for the video. And then I'm asking myself, this times what will give you that last term? Well, I know I need to multiply by -9, and the x minus 1 to the 1/2 is already there. Okay, there we go then. If you distribute that back out, make sure that you've got the original problem. Okay. So the extra step I said I would put in there is just simplifying this to say x minus 1 squared. Okay. Perfect. Your job then is always to simplify what's inside the brackets. I hope you're seeing what's inside the brackets as difference of perfect squares. Okay, because there's 2 terms, if you will, one of them being this, one of them being this, and they are subtracted. Okay, so that is difference of perfect squares. So reviewing that part a little bit, maybe I'll put bracket to make it easier for these 2. In the front of each one, you would have the square root of x minus 1 quantity squared, which would just be x minus 1, and the square root of 9, 3 for each, one's plus and one's minus. Okay. So again, simplifying what's in the brackets, I'm going to have x plus 2, it looks like, for this one. And the next bracket simplifies into x minus 4. Okay. So again, we're looking at x minus 1 to the 1/2 equaling 0. Set each factor equal to 0. Okay, so with parentheses. Or we're looking at x plus 2 equaling 0. Or we're looking at x minus 4 equaling 0. Okay, so however you're going to do this, I am raising this to the 2nd power. All right, so that'll give me x minus 1 equals 0 squared is 0. Looks like I'll get x equals 1. Okay, and I raised it to a power, so I'm going to have to check that one. If I go over here, I'll get x equals -2. I didn't do anything fancy there. I don't need to check that answer. Or x equals 4. Again, nothing fancy there. I do not need to check that answer. Okay, the only thing I have to worry about at the start is that I did have square roots in the problem, right? Because of those roots. Those 2's are roots. So I do need to worry about roots a little bit. Okay, and we'll mention that as we're going through this. Let's do our check step for the x equals 1 that we said we had to do. Okay, so checking the x equals 1, I would have 0. Let's see, if I plug in 1 minus 1, so yes, 0 to the 5 halves minus 9 times 1 minus 1, so again, 0 to the 1/2 power is supposed to equal 0. Well, 0 to any power is 0, and so 0 minus 9 times 0, which would be 0, is 0. 0 does equal 0, so that's a check. x does equal 1, okay? And then you just need to make sure that we are not, for the other two numbers, we need to make sure we are not taking an even root of a negative number if you can't have imaginary numbers. Okay, so again, it might relate back to those directions. Okay, so I need to make sure I'm not taking an even root of a negative number if you can't have imaginary numbers. Now we are in the section where we're allowed to have imaginary numbers. Okay, so we're going to be fine with all of these. Okay, so x equals 1 or x equals -2 or x equals 4. You would put all of them in the answer blank. And we will just make a note here to make sure you aren't taking an even root of a negative number if you can't have imaginary numbers as answers. Okay, we can, in this section, just make sure you're always looking at those directions.